Hello, this is Mrs. Phelps. It is Friday, September 4th, and we are doing the 1.9 section on factoring perfect square trinomials, as well as reviewing factoring as a whole from the chapter, bringing it all together. Hopefully you enjoyed your break from me teaching with Mrs. Murado and Mr. Ferreira's lessons, but hopefully not too much, because that would mean you don't like me. Okay, so this first page again is on 1.9, and the second part is going to be on factoring. And the factoring is important because in all the sections so far we've just done one concept at a time, but now you have to figure out which route to go with the different types of problems. And then so this is your homework for Friday, which you need to do the try this problems, and then we'll be doing the practice problems for 1.9 in class on Tuesday. Since Monday is Labor Day, there is no work to do there. So assuming you watch this video, do the try this problems, take your notes, then you should be all set for Tuesday. So let's get started. For a trinomial to be factorable as what we call a perfect square trinomial, the first and last terms need to both be perfect squares, and the middle term needs to be twice, so 2 times the square roots of the first and last terms. So what does that actually mean? Well, I'm going to go back to something that we did last week, which was when we FOILed. So if we had 2 binomials and we FOILed and we got a polynomial as the result. And we specifically went over when you have special products. So that was when we did like this, a squared, and then we had plus ab, but these were numbers, plus ab plus b squared. And as a result, we had a squared. So notice that's the first term is a perfect square. Then we have 2ab, so that middle term is twice the square roots of the first and the last terms. And that last term is a perfect square as well. So we're just doing this in the other direction. Rather than foiling, like this example, it shows x plus 4 times x plus 4. Rather than foiling this to get to x squared plus 8x plus 16, we're going the other direction now. So again, this forms a pattern, and you can go off of this pattern so that you don't have to go through and actually factor like you would for just a standard trinomial. So looking at this problem, it says 16x squared plus 24x plus 9. Is the first term a perfect square? Yes, it is. And we know that it is because 16x squared, the square root of 16x squared would be I don't know why I put a, would be 4x. So since this represents, looking back down here, we had a squared plus ab plus b squared. 16x squared represents a squared. So a squared is 16x squared, which means that a is 4x. And then this is a typo, which I need to remember to fix. Is the last term a perfect square? So is 9 a perfect square? Yes, it is. So a squared equals 9. That means that a is 3. So if both the first and the last terms are perfect squares, then we want to check to see if that middle term is twice the product of the first and the last. Again, that's because when we distribute, when we FOIL and we get b times a times b, we want 2 of the same thing. So we want to check to see if it's equal to 2 times a times b, because this here was a squared, this was b squared. So if it's equal to 2 times those square roots, then that means that it is a perfect square trinomial. So 2 times 4x times 3. And I wrote a squared and a again, but this should have been b squared and b. Okay, so that comes out to 12x times 2. So that's 24x. Whoa. Okay, so that's what we got. Yeah, so it is 2 times the square roots of the first and the last terms. So because it's a yes to all 3 of those things, that means that it is a perfect square trinomial, and we can follow this pattern. So the pattern is that a squared plus 2ab plus b squared is equal to a plus b times a plus b. So we know that a is 4x and b is 3. So this is going to be 4x plus 3 times 4x plus 3, which is the same thing as 4x plus 3 squared. And you can write it either of these 2 ways. They're both correct. And that's that. So again, before you can just go ahead and take the square root of the first term, take the square root of the last term, and say that this is factored, you do need to check that middle term. The other case is when the middle term is negative. So if we had, for example, here, if we had x minus 3 times x minus 3, that's x squared minus 3x plus 9. And that's x squared minus 6x plus 9. So again, this middle term needs to be 2 times a times b. And as a result of that, we're left with that middle term being 2ab. But in this case, it's negative. So if the middle term is negative, then you just check to see if it's negative 2ab. If it's positive, you just check to see if it's positive 2ab. All right, so looking at these problems, it says determine whether each trinomial is a perfect square trinomial. Write yes or no. If so, factor it. And you can technically factor these problems without even using the fact that it's a perfect square trinomial. I'll go over that after we do this first one. But I do recommend that you try to recognize the patterns so that way you're not spending the time going through and factoring. So the first term, is it a perfect square? So yes, 4y squared. If that's a squared, then that tells us that a is 2y. So the square root of 4y squared is 2y. The last term, is 9. So that means that b is 3. And the middle term, we want to check to see if it's 2 times a, which we found is 2y, times b, which we found is 3. So 12y. Yes, that's the middle term. So that means it is a perfect square trinomial. So we can go ahead and put it in the form of a plus b times a plus b. So a was 2y, b is 3, 2y plus 3. Or again, you could write it as 2y plus 3 squared. Okay, let's look at the second one and make sure that you check all 3 terms, because if we just check the first and the last, it might not work out. So the first term, 9x squared, that means that a is 3x, so make sure you take the square root. And then the second, or the last term is 4, so the square root of that would be 2. And because the middle term is negative, it's okay that it's negative, but when we check it, we're going to be checking if it's negative 2 times a times b. And that comes out to negative 12x, and that is not the middle term. So because it's not the middle term, that means that this is not factorable, which means even if you tried to factor it using our normal method of 4 times 9, coming up with 2 numbers that multiply to 36, add to negative 6, you can't come up with any numbers that work there, so you cannot factor this. If you looked at number 1 and if you forgot these patterns, you can always go back to factoring it how you normally would. 4 times 9, that's 36. 2 numbers that add to 12. And because this is a perfect square trinomial, that number, those 2 numbers are going to be the same as each other. So it's 6 and 6 that add up to 12. So then you could go in and factor by grouping 4y squared plus 6y plus 6y plus 12. And you would end up getting the same result, 2y plus 3 times 2y plus 3. All right, go ahead and pause the video and do the try this. And once you're back from that, that's pretty much it for 1.9. So we're going to be looking at factoring methods, just the overall factoring methods. And this is going to be a quick review of that. So when you factor in general, you first want to look to see if there's a common factor among all the terms. So for example, if we had 2x squared plus 12x plus 10. First, you look for a common factor. If you can take a common factor out, then you do that first. And then you can continue on and factor what's left over. If there's nothing to factor out, or even if there was something to factor out, let's say it was 2x squared minus 8, and we could factor out a 2. You then want to look to see if there's a difference of squares. So difference means subtracting, squares means perfect squares. So is there subtraction of two perfect squares? So you look at that first term, x squared is a perfect square, 4 is a perfect square, and it's subtraction. So that means yes. So check for those patterns. So this one you could go 2 times x minus 2 times x plus 2, because the inner and the outer terms cancel each other out. This was from 1.8 that you watched with Mr. Ferreira yesterday. And then if it is not a difference of squares, so difference of squares means that there's only 2 terms. If there's 3 terms, then you want to check to see if it's a perfect square trinomial. So that's what we just went over. So for example, let's do x squared plus 10x plus 25. So you check, is the first term a perfect square? Yes. Is the last term a perfect square? Yes. Is the middle term 2 times the square root of the first times the square root of the last? And yes, it's 10x. So you'd say because it's a perfect square trinomial, we're first going to fix that writing. X squared plus 10x plus 25. So because we know it's a perfect square trinomial, we can go ahead and factor it as a plus b times a plus b. Again, this was a, this was b, because the first term was a squared, which was x squared, and the last term was 25, which was b squared. Okay, and if you don't have either of those, then your last thing to do is to just start factoring. And if you have 4 terms, then you're going to factor by grouping. If you don't have 4 terms and you have a leading coefficient of a, then you need to break it up and do your 2 separate columns, come up with your factors, and then you'll end up forming it into 4 separate terms. If there's a leading coefficient of 1, then remember you can just do the shortcut there. So if it was x squared plus 6x plus 5, then you can just come up with 2 numbers that multiply to 5, add to 6, that's 5 and 1, and then go straight to x plus 5, x plus 1. Remember, you cannot do this though if there is a leading coefficient. So let's say we had 2x squared plus 3x plus 1. So you'd need 2 numbers that multiply to 2, add to 3, that's 2 times 1. And then you have to go ahead and break up that middle term. So remember, we're replacing the 3x with 2x and 1x. And then you factor by grouping. So that's kind of the overview of factoring from chapter 1. And